of a rectangle is length times width. Length times width. Length times width will give us area of a rectangle. The third one that we are going to check here is a square. And a square here, I have it as side squared. Side squared. Why do we have side squared? This is the short form of side times side. This comes about because of the following properties of a rectangle. Number one, all the sides are equal. All the sides are equal. Two pair of parallel lines. Two pair of parallel lines. And when you talk about parallel lines, we know these are lines that do not meet. The lines that will never meet. Number three, the corner angles are 90 degrees and the sum of the interior angles add up to 360 degrees. And that brings us to the last part, which is formula, which we say is side times side. The short form of side times side is side squared. So far, I've talked all three shapes that we are going to tackle in this area. Shape number one, rectangle. Formula, length times width. That's formula of getting the area. Shape number two, square. Formula of getting area, side times side. Shape number three, circle. How do we get area of a circle? Pi r squared. Pi r squared. Area over a circle. Good. And this one will lead us to our next example of shapes that we are going to see. As I mentioned earlier, the first shape we are going to talk about is a cylinder. Is a cylinder. I said a cylinder is made up of three parts. A cylinder is made up of three parts. We have the top, which is circular in nature. We have the bottom, which is also circular in nature. We can call them sisters. We can call them sisters because they're the same. Then we have the curved part. That part that is curved. That part that is curved. Remember, when you open that curve, it always forms a rectangle. And remember, formula for getting area of a rectangle is length times width. In this case, we'll see what we are going to use. Good. So this is the cylinder. This is the cylinder. This is the curved part I was talking about. This circular part is the curved part, the way it is round. And then this one here is the top. As you can see, it is circular in nature. The shape is a circle. This top is the same as bottom. Bottom is the part that is resting on the ground. That's why we call it bottom, because it is resting on the ground. That's why we call it bottom. So we have top, bottom. They are identical. They are the same. These two shapes are the same. So this one will give us the formula of the area of those two parts. Remember, one of the parts we say pi r squared. That is the area of one circle. Pi r squared. That is area of one circle. But now there are two. We simply add 2. Then you say 2 pi r squared. 2 pi r squared. Then we come to the third part, which is the curved part. This part round here, we call it circumference. And then circumference, when we open it, it will look like a rectangle. So for us to get area of a rectangle, we said earlier it is length times width. So this part here, we'll not call it length at this point. We'll call it circumference. So we call it circumference. And let us remind ourselves, what is circumference? Circumference is the distance all round a closed figure. Circumference is the distance all round a closed figure. So that part is called circumference. And what is the formula of getting area of circumference? Is pi d. Formula of getting area of circumference is pi d. Formula for circumference is pi d. So in this case, we'll take pi d, we multiply by h. So we say formula of getting circumference is pi d, and circumference, I've said, is the distance all round a closed figure, rather a circular figure. A circular figure, that's circumference. So circumference is pi d, and then we multiply by h, our height. So we have pi d h. In total, we will get the formula of working out a cylinder as 2 pi r squared plus pi d h. 2 pi r squared plus pi d h. Why do we say 2 pi r squared? I explained earlier, 2 circles, the formula of one circle, pi r squared. Formula of one circle, pi r squared. Now there are 2 pi r squared plus curved part, circumference times height, giving us pi d h. Pi d h. We'll move to the second shape, and the second shape is a cuboid. A cuboid, in our normal daily activities, we always have it. It looks like a box. So a cuboid is a box in short. So in our daily normal activities, we have a box. So that box that you always see at home is a cuboid. So how can we get surface area of that cuboid? When it is closed, means that there is no space anywhere. We'll have 2 identical parts in each case. So first of all, to get what a cuboid is, number 1, it is having 6 faces. A cuboid is having 6 faces. Number 2, these 6 faces, we have 2 opposite faces which are all equal. These 2 faces we have opposite which are equal. For the 6 faces we have 2, 2, 2 which are equal, as we are going to see in the diagram. Number 3, all these faces, when we talk of a closed cuboid, all of them are there. No face is missing, so we talk of closed. So look at the first cuboid, which we say it is closed. This part here, this is called top. It's called top. And then down, when it is resting with, we call it bottom. I say bottom is where a shape is resting on. That part we call it bottom. So this part down here is bottom. So which shape are they? They are in rectangular shape. They are in rectangular shape. Earlier on, we said formula of getting area of a rectangle is length times width. Formula of getting area of a rectangle is length times width. So here we have 2 rectangles, top and a bottom. So what do we say? We'll get area of 1, we multiply by 2. So it will be length times width. After getting the answer, multiply by 2. We are going to see how we always put the formula and come to this face facing you, this face facing us. This one here is also in a rectangular shape. As you can see, it is also in a rectangular shape. And this face in rectangular shape is having the other face, this side, the other face, that side, which is the same, exactly the same as the first face. So this faces facing you is also having another one. Which shape is it? A rectangle. It is a rectangle. How do we get area of a rectangle? As said, length times width. How many are they? 2. How many are they? 2. So we'll get the area of one face, we multiply by 2. We come to this face that is facing away from us. This one, we always call them the cross-sectional faces. This face that is not facing us. This face and this face also facing away, this side. They are the same. These two faces are the same. They are also in a rectangular shape. So they're in rectangular shape, but from here going up, we call it height. We call it height. And from here going the other side, we call it width. And then this one I did not mention, it is what we call the length. So we have length, width, height. So in this case, instead of, it is in the rectangular shape, it's only that the name here changed to height. Instead of saying length times width, we'll say height times width, height times width, or width times height. And they are 2, and they are 2. So that is all about the faces of a cuboid, a closed cuboid. 6 good faces, each identical faces. We have 2 pairs of identical faces, top and bottom. The face that we said facing us and the face that is facing away from us, those 2 faces are also the same. The cross-sectional faces facing away are also the same. They are also equal. So let's come to the formula of a closed cuboid. We'll say surface area equals to 2 into length times width. That is area of top times 2. 2 into length times width. Area of top times 2 plus area of the other side. This side here we have 2 into length times width. 2 into length times width. Then we have plus 2 into width times height. 2 into width times height. We work out area of this one, length times width times 2, that is area of top and bottom. We come to area of this side, this face, we say length times this one, and then there are 2 multiplied by 2. So I call it width because it is a rectangle in nature. You can see it's a rectangle in nature. Then we come to the last part, we say width times height. This width times this height. And we have the initials as we use. Surface area is equals 2 into length times width plus 2 into length times width, that is for this one, plus 2 into length times height, that is for this one and this one. That is all about a closed cuboid. That is all about a closed cuboid. We said surface area of a closed cuboid, 2 into length times width, close the bracket, plus 2 into length times width, close the bracket, and plus 2 into width times height, close the bracket. And that one will give us the area of a closed cuboid. Let's come to the second type of cuboid, and this is what we call an open cuboid, an open cuboid. Why do we say open? We say open because there is a part which is missing. There is a part which is not there. Take a good example. When you are from outside, you are going to the house, you get it locked. We say the house is not having any space we can go in. And when the door is just open, we'll get through because there is a space. So the same apply to our cuboid. One of the faces has been removed. It is not there completely. So how do we go about this? So one face is missing. Remember, in closed, all the faces were there, and we are using the term 2, 2, 2, 2. 2 into 2 into 2 into. Let's come to the third, to this figure and see. This is the shape. This part here is open. This part here is open. The part is not there. So if the part here is open, yes, the part here is open. The part does it mean we have gone for break? I don't know. Now we have the second part, and this shape, and this shape is now cuboid with this part not there. This upper part is not there. This is the part that I call the top. So the top is missing. If the top is missing, we say it is opened. If the top is missing, we said it is opened. So when we'll be calculating the area, we'll be calculating the area minus one face. So not all the faces are going to be multiplied by 2, because one of the face is missing its twin or its identical face. All right, see, we say the top is not there. So what will be the formula of getting area of top? It will simply be length times width, because it is only the bottom part that is there. It is only the bottom part that is there. So we'll simply say length times width. Right, we come to the next face, which is length times height. Length times height. So length times height, we have this face and the other face this side. So how many faces are there? They are 2 faces. They are 2 faces. Therefore, we'll say 2 into length times height. 2 into length times height. We come to the third face, the face that the cross-sectional face that is away from us, and the face here we have, we'll call this one height, and then we'll call this one width. There are 2, so we say 2 into height times width. 2 into height times width. Those faces are 2. The only face that is missing, is top, and that's why we say open. And I want you to be very keen on this. Always identify the face that is open. It is not a must that it will always be top. Sometimes it can be the cross-section side. Sometimes it can be the face that's facing us. So be very keen on the top that is open. So that top you will not multiply by 2. Like in my case here, it is the top that is open. And most people assume it is only the top that is always open. This face can also be missing, and we have top and we have the remaining parts. So be very keen on checking which face is not there. Now, those are the two types of cuboid, and those are the formulas getting area of the cuboid. We've said, number 1, you have a closed cuboid, 2 into length times width plus 2 into length times width. I say that width, you can replace it with height, but remember, you know the measurement and you know what you're writing. Then 2 into length into width times height. That is the formula of a closed cuboid, as you see here and as we discussed earlier. Open cuboid, I've said be very keen on the face that is opened. So after you've realized the face that is open, you'll continue with the formula as it flows. You check, in our case here, it was top. So we say surface area is equals to length times width, bracket, plus 2 into length times width, plus 2 into width times height, because we identified the face that is open and we've used the formula appropriately. Okay, good. This one will take me to the third shape. The third shape, as you can see here, the third shape is a cuboid. The third face is a cuboid. What did we say about a cuboid? 6 sides are equal. All the 6 faces are equal. That is a cuboid. All the lengths are equal. All the lengths are equal. And let's say the faces are identical. So getting surface area of a cuboid is a bit easier. We simply say get area of one face, then multiply by 6, because all the faces are 6. As we can see here, we have face 1, face 2, face 3, face 4 the other side, face 6 on top, and then bottom. All these faces are equal, they are identical, they are the same. So we simply say length times length, because you can decide and call it this side and this is side. They are the same. You can call it length and this is length. They are the same. Even if you say side times side, remember to finally multiply it by 6. Remember finally to multiply it by 6. Even if you say side times side, remember finally to multiply it by 6. Somewhere you will get that the formula is written, like in this case we've used length, it will be written L squared. L squared, then they tell you, they will say L squared like this, then multiply by 6. That simply means that the answer you get after multiplying what is inside the bracket, multiply it by 6. L squared comes from length times length, and as I said, sometimes it can be called side. You say S squared, then multiply by 6. Between the bracket and 6 here, there is a multiplication sign that is always silent. So we normally leave it like that. So these are the three of the formulas you can get. Length times length, then we multiply by 6, length squared, then we open the bracket by multiplying by 6, side squared, we open the bracket by multiplying by 6, and that's all in area of a surface area of a cuboid. L times L. The answer, the area of one face, multiply by 6. All those faces are the same. So get face of 1, then multiply by 6. And that's all about the formula of a cuboid. And this one will take me through to what is the KCP setting trend of surface area. What is the KCP trend in setting surface area of solids? Okay, we'll first check in 2009, that is in 2009, there was one question in 2009, that was number 29, as you've seen. Then in KCP 2011, you get that 2010 we had no. So in 2011, we had one number 18. In 2012, we have number 37, that is surface area, number 37. That's 2012, I mean. In 2013, we have number 25, 2013. Then in 2015, we had number 42, that is surface area of solids, In 2016, we also had number 38, surface area of solids. And also in 2019, that was just last year, we had one on this surface area of solids. So you get that surface area is a common question in KCP. Surface area of solids is a common question in KCP. So we have to familiarize ourselves with this setting trend, and this one will only help us if we know how to work out the surface area of a given solid. First of all, look at the solid. Which shapes do I have? Is it formed using a circle? Is it formed using a square? Is it formed using a rectangle? What is the formula? Get the formula in your fingertips and we get the area. We'll go direct and look at one example in surface area. And we have a question here. Example 1. What is the surface area of a closed cylinder of radius 3.5? What is the surface area of a closed cylinder whose, we are saying that it is a surface area of a closed cylinder whose radius is 3.5, surface area of a closed cylinder 3.5, and we also have height of 18, that is the height, pi 22/7, that is our pi 22/7. We come to the formula we learned earlier. Surface area, it will give us area of top plus area of bottom plus area of curved. So let me just have a sample of a cylinder here. We have a sample of our cylinder here. So this cylinder is that. So I've said area of top, and where's the top? This is top. And area of bottom, this is bottom. And area of curved, as I said earlier, this is the curved part. Area of curved. So area of top and area of bottom, we realize that they are the same. This one and this one, they are the same. Therefore, instead of getting separate area, since they have same formula, the faces are the same, we come and say surface area is equal to 2 pi r squared, that is for top and bottom combined, plus pi d h. 2 pi r squared plus pi d h. The radius is 3.5. The radius is 3.5. So we'll say 2 times pi, which is 22 over 7. 2 times pi, which is 22 over 7, times 3.5 times 3.5. So because we have r squared, remember we said earlier, r squared is the same as r times r. So we'll have 3.5 times 3.5 plus area of curved part. Curved part, as we see here, is pi d h. So pi 22 over 7 times 7, because the radius is 3.5. The radius is 3.5. Therefore, the diameter will be 3.5 times 2, which is 7. So times 7 times height, which is 18. So we do our calculations. 7 here, 1, 7 here, 7 will go there, 0.5. 0.5. When we multiply 2 times 22 times 3.5 times 0.5, we'll get here 77. Then here we come to the pi dh. 7 here, 1, 7 here, 1. 22 times 18 will give us 396. So we put them together as indicated here. We get our answer here as 473 square. They should be square centimeters. That is always our unit, square centimeters. In any time you're working area, anything called area, anytime you are working anything called area, be it surface area, area of a square, area of a rectangle, area of a circle, we will always have the units as square. Be it meter square, kilometer square, centimeter square, we'll always have the units as square. And let us look at our example 2. Find the surface area. Find the surface area of a closed cube of side 12 centimeters. Closed cube of side 12 centimeters. So, number one, we say the cube is closed. All the faces are there. The cube is closed. All the faces are there. Therefore, surface area of a cube will be equal to area of one face, this one, area of one face, area of one face, then this area of one face, we multiply it by 6 because of the 6 faces. Because of the 6 faces. Area of one face, then that area of one face we multiply with the 6 faces. Remember the formula? Length times length, bracket, multiply by 6. And that one will give us area of, surface area rather, of a cube. Surface area of a cube. Surface area of a cube. Let's see. So here we have the lengths are 12. All the lengths are 12. Of that cube, the lengths are 12. It will be 12 times 12. The answer we have, we multiply by 6, giving us here, it will give us here 864 square centimeters. 864 square centimeters. This is very interesting with the cube. Area of one face, multiply by 6. You are done. You have your surface area. As we said, all the faces are equal and the same. Let's come to another example. Find the surface area of a closed cuboid. And keywords, underline the keywords, closed cuboid, shown in the figure below. The cuboid is closed. What is its surface area? The first thing that should run into your mind, what is the formula of a closed cuboid? 1, we'll get the surface area of the 6 rectangles. Remember, a cuboid is made up of 6 faces. All these 6 faces of a cuboid are rectangular in shape. So we get the area of all the 6 rectangles according to the formulas we have. We go. Area of 2 faces measuring 8 by 6. Area of 2 faces measuring 8 by 6. You say 2 into 8 times 6, which will give us here 96. That is area of one face gone. Area of 2 faces measuring 6 by 10. Area of 2 faces measuring 6 by 10, which will be not 6 by 10, rather 8 by 10. So there are 2. We say 2 into 8 times 10, and this one will give us 130 square units, square centimeters, I mean. And we come to the third area of 2 faces measuring 10 centimeters by 6 centimeters. There are 2 faces, so we say 2 into 10 times 6. This one will give us here 120 square centimeters. Just to come back, this one is according to the formulas. This one is according to the formulas that we have of our cuboid. The formulas we have of our cuboid. Let's look at the cuboid first of all. This is the cuboid. This the face that this is the one that is measuring length, the measurement for length, and this one for width, which is 6, and this one is for height, which is also given here as 8. So multiply area, as we say, 2 into length times width plus 2 into length times width for the side that is facing us plus 2 into width times height. And that one is clearly indicated here when we talk of area of 2 faces measuring this by this. And now we come to get the total surface area. We'll add all the area of the 6 faces. The first 2 faces gave us 96. The second 2 faces gave us 160. The third 2 faces gave us 120. So when we put the 6 faces together, we'll arrive at 360 376 as our surface area, That's about a closed cuboid. You know, when it is open, you know which face is not there. When it is open, you know which face is not there. Example number 3 is this one. This is a cylinder. What is the area of the curved surface area? What is the area of the curved surface of the cylinder below? I said underline the key words. Underline the key words. Somebody will just rush without underlining the key words and then work out the surface area of the cylinder. But look at the question. Very key. What is the area of the curved surface of the cylinder? Curved surface, not what is the area of this, what is the surface area of the cylinder. So be keen. Identify the key part of the question, and this key part of the question will simply lead us where we will get our solution. So area of curved, I said curved part is this part that we are seeing here. This part, this is what I said is curved. Yes, if that is our curved part. And I said when you're working out curved part, you multiply circumference times height. You multiply circumference times height. And what is the formula of getting circumference? Circumference we say equals to pi d. Circumference is equals to pi d. Therefore, this one will simply give us pi d h. We are multiplying by h. Pi d h. And check on your shape always. Don't get confused. If the shape can be in this form, it can be drawn like this, slanting along the ground. This one will still be our h, and now we'll call it length. And this one will still be our circular part, which will say circumference equals to pi d. And now instead of h, you say pi d l. Instead of h, you can say pi d l. And whether you use pi d h in this case, but remember what is h. You should know what is h. The same shape can be drawn. You can be told, not drawn, you can be told that a swimming pool was dug under the ground. The swimming pool was dug. After the swimming pool, then this one will be given. Remember this now, the ground, our ground will be somewhere here. So you go down. So this one going down, we call it breadth. We call it breadth. And when you will be asked its surface area of the curved part, remember the formula. So we say the formula of working out area of the curved surface of the curved part, we say circumference times height, as I have indicated here, circumference times height. Circumference itself is pi d. Circumference itself is pi d. Or instead of saying pi d for circumference, you can also say 2 pi r. Circumference can be pi d or 2 pi r. So this one will make a simple change in this formula and will say is equals to 2 pi r h. 2 pi r h. As we have used here, we said 2 pi r h. 2 pi r h, because circumference is given by two formulas. The first formula of getting circumference, you can say pi d h, or whereby d is diameter. And the second formula, you can say 2 pi r. 2 pi r. 2 will stand for the two radius that will make up the diameter. So we'll have 2 times 22/7 times our our radius, our diameter here, which is 1.4 times 10, and when we multiply these ones, they will give us 800, and they will give us here 880. They will give us 880, and that is circumference of the curved part. That is circumference of the curved part. At the same time, we can be given circumference to work out the surface area of a closed cylinder, as I elaborated earlier, whereby we say 2 pi r squared. But what about in a case we are given this one here? What about in a case we are given a cylinder? We have a cylinder, and then we've been told that this cylinder is open on the top. It is open. This is not there. This is not there. The formula we use will say we'll have area of bottom, this bottom part. We'll have the area of the bottom part. We'll have the area of the bottom part. Area of the bottom part, which is a circular shape, which will give us pi r, will give us pi r squared, and plus area of the curved part, which will be pi dh. So this is only if the cylinder is opened at the top. If the cylinder is opened at the top, and the cylinder can only be open on one part. The cylinder will only be open on one part, and that is the top. The cylinder will only be open on one part, and that is the top. So we'll exclude surface area of one part, that is the one top, and then we work out the surface area of the other part. Okay. Now we have some questions with me, and let me just get the questions so that can go some questions from my students, my pupils. And question number 1. Let's get question number 1. We have question number 1. Okay. Question number 1. Leon asked, how many vertices, edges, and faces does a cylinder have? How many vertices, faces, and edges does a cylinder have? Leon will have this diagram here. This is our diagram. This is our diagram. And this is a diagram of a cylinder. This is a diagram of a cylinder. This is the diagram of a cylinder. This is the diagram of the cylinder. Now, how many faces do we have? In this cylinder, we'll talk of 3 faces. If it is closed, we have top, we have bottom, and then we have the curved part. This is a face on its own. Remember, when we open the cylinder, we'll have that one, we'll have this one. We are opening the cylinder, and these are the faces we'll have on our cylinder. The cylinder will have these 3 faces. This is how we open the cylinder. This is what is made up of the cylinder, because this rectangular shape, this one here, will make our curved part. This one will make our top. This one will make our bottom. So top, curved, bottom. So the faces are 3. We have 3 faces. Let's come to the vertices. Let's come to the vertices. Let's come to the vertices. First of all, what is a vertex? What is a vertex? A vertex is whereby 2 or more faces meet. Where 2 or more faces meet. Look at the vertices is that a vertex is that point. We have the point where we have the joining of particular lines. For example, let me just have an example. This one like this, like this. So this point here, where 2 or more lines meet, that we call it a vertex. A vertex. So when there are many, we call them vertices. So let's look at our cylinder. This is the cylinder. If you look at the cylinder clearly, we can't get the vertex. Let's look up there. We don't have that vertex. We don't have a vertex in a cylinder. And what about the edges? The edges. An edge. An edge, for example, is where 2 or more faces meet. That is what we call an edge. So one face meets another. So in our cylinder, we have 3 faces, and these 3 faces meet at different points. This face here, this face, it meets this face along this line. And this face here, this downer face, it meets the curved part along that line. So in that case, we can have the 3 edges. We can talk them, or we can talk about 2 edges. We cannot talk about 3. We talk of 2 edges because the same face, this one meeting the top, the same face meeting the bottom. So those are the edges. There are only 2 along the edge of a cylinder. There are only 2. So we'll have 3 faces, 2 edges, and here we have nothing. Okay. We have Yvonne from Zero. Yvonne from Zero is asking how we can get. Yvonne from Zero is asking how we can calculate surface area of an open cube. Surface area of an open cube. Thank you, Yvonne, for that question. And this is how we work out surface area of an open cube. Let's have an example of a cube here. Our cube here, that's a sketch drawn of a cube. So this is our cube here, Yvonne. So Yvonne, this part is open. This part is open. This one is open. It is not there. Remember I said when it is closed, we say length times length. This one you multiply by 6. But now one face is missing. What do? It will be length times length. One face is not there. Multiply by 5. Length times length, multiply by 5. Because one face is missing. When it is closed, length times length times 6. When it is not there, one face is missing. Length times length times 5. One face is missing. Fiona is asking for area of an open cylinder and the area of a closed cylinder. I think we tackled them earlier, but I will just give you how we go about area of an open cylinder. This is our cylinder. So this is the cylinder. This part is open, and I said a cylinder can only be open on one side. So how do you get the formula of open cylinder? So surface area of open cylinder is equals to area. Surface area will be equal to area of bottom. This is our bottom. This is our bottom. This is our bottom. area of bottom, which is a circle, so we say pi r squared plus area of curved part, this curved part, which is pi d h. Area of the bottom, pi r squared, plus area of the top of the curved part, pi d h. For example, let's say here you've been given as the radius as 7. The radius is 7, and then the height here is 10. So we'll say this one equals to 22 over 7 times radius 7 times 7. This one is for the bottom plus pi dh, that is for the curved, 22 over 7 times diameter. If radius is 7, diameter is 14 times 14 times height 10. Sawa. So we simplify by cancellation. Here 1, here 1. So 7 times 22 is 154 plus, for this one, 7 here 1, 7 here 2. The 2. 22 times 2 is 44. 44 times 10 is 440. So we put these two together here, 44. So yani 49596. That is when it is open. That is when it is open. Okay. Question number 3 is coming from Abigail. What is the area of borders? What is the area of borders? Oh, thank you, Abigail, for that question. And area of borders, we don't deal with area of borders in surface area. We have a subtopic on its own, area of borders. And just to answer you, area of borders will depend. Area of borders will depend with which border are we talking about, which shape do we have that we are asking its border, because we can have a circle, we can have a square, we can have a rectangle, or in that case, let me just give you one example so that you can be clear on that, Abigail. So for example, we have this one. Oh, sorry for this one. Then they have here. Maybe this part is shaded. This part is shaded. So that shaded part is what we call a border. So we'll talk area of border in differently as areas of surface area. Surface area, as I said when we started, is the area of all the faces that we have, then we put them together. Area of all the faces that we have, then we put them together. Thereby, we are talking area, surface, total surface area. Area of borders, I've mentioned, we have different shapes. We'll be asked to work out different area of the borders. So we'll see about it in our next lesson. Esther is having questions here. Question number 1. A closed cylinder is measuring a closed cylindrical tin measuring 14 centimeters in radius and 30 centimeters height was painted white on the outer part, excluding the top and the bottom parts. What is the surface area painted? Good, Esther. A good question for that matter, Esther. Let me just use very fast. Esther, when we talk of a closed cylinder, it was painted white on the curved part only. It was painted white on the curved part only. What does the question ask? The question simply asks for what is the surface area of the curved part. And bringing this one to our attention, remember, we can also be told it was wrapped using a piece of paper. So what surface area was covered by the piece of paper? So let's have, for the Esther's case, this one here is our closed cylinders of radius measuring radius, radius here, not diameter. The radius measuring 14 centimeters, and the height is 30 centimeters. So in this case, the question simply asks for the area that was painted white, excluding means do not include the top and the bottom. It's only the curved part that was painted. Top and bottom, leave them. This is how we go about the question. Okay, the first thing, as I will insist, always put your formula down. Surface area is equals to, it's only area of curved part. Surface area of curved is equals to pi d h. Surface area of curved part, pi d h. I explained that it is circumference. Earlier I said it is circumference times height. Circumference times height. Therefore, we'll simply say pi d, because formula of getting area of circumference is pi d. We mentioned that one earlier, the circumference is given by pi d. So here we'll say circumference times height. Circumference times height. Therefore, this circumference is replaced by pi d. So we say pi d h. So this one will be equal to 22/7 times, radius is 14. Our diameter will be 28. Our diameter will be 28. So this 28 we multiply by height, which is 30. This 28 multiplied by height, which is 30. So we'll say area is equals to surface area of the curved part is equals to circumference times height, whereby the circumference is pi d. Circumference is pi d, which we have 22/7 times diameter, which will be 28 because the radius is 14, times height, which is 30. So when we simplify by cancellation, we'll say 7 here, 1, 7 here, 4. So we'll have 22 times 4 times 30. 22 times 4 times 30, and this one will give us 22,640 square centimeters. 2,640 square centimeters. I will go over the question again so that we understand better. The question, this one was painted white, and that one simply, it is the curved part. This curved part was painted white, this one. So we say surface area of curved part is equals to circumference times height. Circumference is given as pi d. Circumference is given as pi d. Circumference is simply this distance going around this shape on top. So it will be pi d h, 22/7 times 28 times 30, and that one will give us, we use simplification by cancellation, we get 7 into 28, 4. Then that one will lead us to multiplication. We get 2,640. 6,240. How question that follows, how will you work a question in an open cuboid? Very good. how will you work a question in an open cuboid? We simply gave out the formula, but we did not work it out. Let's see. Let's see. Let us get one here. Okay, so we have here one question, number 3 in this case. Number 3 in that case, we have that one. An open rectangular tank has a base measuring 2.0 meters by 1.5 meters. It has a height of 2.5 meters. The surface area of the tank was painted. What was the total area painted? This is the same as the question that we've been asked. How can we work out area of an open cuboid? So we'll start by having our formula down. Remember, first of all, let us have the cuboid. It is a rectangular cuboid. Let's have the rectangular cuboid here. Let's have a rectangular cuboid here. That's our rectangular cuboid. It was open. The base measuring 2 meters. 2.0 is the same as 2 meters. 2 meters by 1.5 meters. So here is 1.5. That is the base. And what about the height? The height is 2.5. 2.5. Okay. What is the formula? What is the formula? We come to our formula and we say formula of open surface area of open cuboid is equals to length times width. Remember, it is open. Length times width plus 2 in sorry, this bracket should not be here. This bracket should not be there. Plus 2 into length times width. I say you can call it width or you can call it height. Then plus 2 into width times height. 2 into width times height. So you come to our measurements. We come to our measurements here. We come to our measurement here. So the base is, since the top is not there, this part here is open. This is open. This is open. We come to this one here, this bottom part. So we'll have the bottom part down there. So this is what we are going to work out. The length is 2, the width is 1.5. So we'll say length times width, which will give us this equals to 2 times 1.5 plus we come to 2 into, let's get our unit here, 2 into length times width, another length times width. That is now for this face here, this face facing us there. It is 2 by height. The height is 2.5. So it will be 2 into 2 times 2.5, close the bracket, plus the third part, width times height. Width times height. So our width is 1.5 plus we have 2 into width times height, 2 here, plus, not plus here, just a mistake here, 1.5 times our height is 2.5. That's all about those shapes. We simply multiply. When you multiply this one, you will get 3 plus we multiply this 2 times 2.5, you get 5. 5 times 2 is 10 plus this one here, we multiply this one. So you when you multiply decimal numbers with decimal points, assume the decimal. After assuming the decimal point, multiply as if you are multiplying whole numbers, then finally insert the decimal point. So in short, I'm saying you multiply 15 times 25. 15 times 25 is 375. How many decimal places? 1, 2. You insert from the right. 1, 2. So here, so we'll have 3.75. When we add these ones, we'll get 3 plus 10 is 13. Then 13 plus 3.75 will be 16.75 square centimeters. So far, those are the questions, and to just conclude, I will urge you on one thing. Okay. On conclusion, I'll just tell you, always follow the formula. Check on your accuracy. That is where I was talking about which part is open, what is the measurement, what is the length. Be very accurate, check on time. Formulas must be followed so that you arrive at the correct answer. Thank you so much, my pupils, for listening. Have a nice day altogether.
University. This is all what I've heard about campus. Campus is full of freedom.
Ni cumulative.
Mchezo hiyo ili poka gani kwani?
Student, and I mostly hang out at shopping center. I'm an arboretum, and what I'd tell first years is it's never too late to start being serious.
Hi, my name is Kimunjo Esther. I take education, chemistry and mathematics.
I'm Songa Daniel, a final year statistics and